In example 3, we're going to take the volume when we take the area of y equals log x. So I've drawn in black here, y equals log x. And we want to find, we're going to rotate this area here, and it's going to be the area from -1. So I'm going to maybe just draw this in here from my lower bound of -1. So down here, all the way to +1 up here. Okay, so this area, we're going to, oops, I'm going to use the yellow here. This area here, we're going to rotate, but this time we're going to rotate it around the y-axis. Okay, so this is slightly different. So what does this look like? Well, I'm going to just maybe try to sketch this curve out here like that. Okay, and when we take this area and we rotate it, I'm going to end up with this horn-looking shape. Okay, and our cross-sectional slices are going to be circles like that. Okay, so I've kind of drawn this down here. Again, you can see that if we slice it along the y-axis, we're going to get cross-sectional circles, and we get this kind of bowl-looking object. Okay, now what's different about this? Well, if I take slices, to get my circle areas, I got to take my slices this way. And if I take my slices this way, the thickness of the slices now has to be measured. Let me just draw that in again. The thickness of these slices are going to be measured with dy. Okay, well, the other thing is, to generate the radius of these circles, the radiuses are now horizontal. And these radiuses are actually, if we measure, since we're measuring from the y-axis, the length from here to here, that radius is really in terms of x. Okay, so we have our radius in terms of x, we have our thicknesses in terms of y. Well, those aren't really compatible dimensions to work with. So we're going to have to change our perspective. So instead of using y equals log x, really I need an x equals equation because I need my radius in terms of length of x expressed with the variable y. So I'm going to rearrange this, and I'm just going to rewrite it in its exponential form. And what this does by rewriting it in its exponential form is that it now allows me to express the radius in the horizontal direction. And not only that, when we integrate this, we're going to have a variable y to integrate with dy. So in the previous problem, we rotated around the x-axis. We needed thicknesses of dx. If we rotate around the y-axis, we're going to take horizontal slices, and those slices are going to need a thickness of dy. So now I can set this up, my circular area. So if you can imagine the circle here, the area of that circle is going to be based on a radius of x, which this is going to be expressed with e to the y. And so the area works out to be area equals pi r squared. And the r is e to the y. So now I have my expression for area. I can now find the volume by taking all these circular slices with thickness, stacking them all up to get that volume. And my volume expression now looks like this. Volume is equal to pi r squared times a thickness of dy. So I'm going to give that a thickness of dy. My radius was e to the y. And I'm going to integrate this. Well, my bounds of integration work with this as well because my bounds have to be in terms of the same variable. It's going to be from -1 to +1 along the y-axis. So there it is. There's my expression for volume. I can now work this out. I can simplify this first of all to e to the 2y dy. Again, notice that the integral is in terms of y and dy, which is compatible. So we end up with pi e to the 2y. Since we're integrating, we need to divide by 2. And then from -1 to 1. And then working out this integral is going to be, actually I'm going to pull that 1/2 out. So I'm just going to express this as pi over 2. And this is going to be e squared minus e to the -2. And as a decimal value, we can work out that decimal value. And that will be e squared minus 1 divided by e squared. And that's going to give us 7.25. So then timesing that by pi and dividing by 2, we end up with 11. This volume works out to be about 11.39 units cubed. Okay, so I would maybe just leave in exact values in that previous line, but if you want the decimal value, there it is.